Hey guys, I am the math professor Kyle Martin, and these two problems, what we're going to do is solve these radical equations. Okay, they're relatively basic as far as radical equations go. And then we also have to check our answers for extraneous solutions. Okay, sometimes you can do all that work and you end up with something that actually isn't a solution. But let's try it. This first one says x equals 7 square roots of x. Okay, so my first instinct would be maybe to divide the 7 over, and you can do it that way. But easier than that is let's just go ahead and eliminate this radical by squaring both sides. Okay, by squaring both sides, this gives me x squared equals, then 7 squared is 49. And then remember, the square and the square root are going to cancel here. So it's just 49 times x, because those will be canceled, right? It's not x squared. It's not the square root anymore. It's just x. All right, then once I have it like this, now I might move that 49x to the other side. Gives me x squared minus 49x equals 0. I see these both have an x in common, so I can factor out an x, leaving me with x minus 49 equals 0. And then either x could equal 0, right? Because if x was 0, then x times, or 0 times whatever this would be, give me 0. All right, so that would make this true. Or x could be 49, right? 49 minus 49 is 0. 0 times x would still be 0. So either x equals 0 or x equals 49. All right, now I need to check both those, make sure that they work. If I check 0 first, plug it back to my original blue problem. 0 equals, and then 7 times square root of 0 is 0, so 7 times 0 would be 0 over here. 0 does equal 0. Since that's true, that solution works. Okay, let's try 49. Let's try 49. 49 on the left side equals, and then 7 times, and then the square root of 49, of course, is also 7. And 7 times 7 is 49. Also works. So both of those are okay. There's no extraneous solutions in that problem. All right, number two. Number 2, this time not a square root, but a cubed root. A cubed root of 4x plus 11 equals negative 3. Our root is already isolated, so we can go ahead and cube both sides, not square, but cube. And that'll cancel the cube and the cube roots there on the left side, leaving you just 4x plus 11. And then on the right side, remember, negative 3 cubed is negative 3 times negative 3 times negative 3. If there's just 2 of those, or any even power, that would be a positive. But since I have 3, right, negative 3 is positive 9 times another negative 3 gets me back to negative 27. So it actually is negative. Over there, be careful with that. All right, and then this one we just solve for x. This is a basic algebra 1 problem. Subtract 11 on both sides. 4x equals negative 38. Divide by 4, divide by 4. X equals, I think that can simplify to be, negative 19 halves. I think is what that is, negative 19 halves. So, only one solution here. Let's plug it back in and see if it works. I might write this one out. So for my original, it would be 4 times negative 19 halves plus 11 equals, that's it's all in the cube root, equals negative 3. Okay, so we can do some simplifying on the inside of this cube root. I'm going to simplify this just to be 2. 2 times negative 19 is negative 38. Negative 38 plus 11 gets me to be negative 27 on the inside of that cube root. And yes, we know that the cube root of negative 27 is in fact negative 3. And so that does equal the other side if I bring that all the way down. And negative 3 equals negative 3. So x equals negative 19 halves is a solution that works. Again, no extraneous solutions in this problem.